Hey Stepsters, I'm Lasya.
And I'm Kritika, and we're your trainers from Future Steps.
Today we'll be looking at straight lines and geometry of straight lines.
So let's get started with how this thing. So we're going to talk about, first off, we're going to start with linear graphs. Now, I know you can't see it too well, but this is our y-x graph or xy graph. And we know that linear graphs always have an equation of y equals mx plus b, where m is our slope and b is our y-intercept, right? And this is always a straight line. The reason why we have this in the straight line thing is just because it's a straight line, it goes on forever. So both of these ends will go to infinity. And then this is our y-intercept, this is our x-intercept. Every single one of them have a y and x-intercept as long as it is not equal to a constant. If it is equal to a constant, then that would have no x-intercept. That would have just one y-intercept, and it'll be a straight line, completely horizontal, parallel to the y-axis. And this is our linear graph. But then if we had a horizontal line type of graph, which would be something like this. So let's say this is our y and this is our x. So if we say, let's say I want to draw y equals 1. And this is 1, this is 2, this is 3. And that line would be right here. So notice how it only has a y-intercept, no x-intercept, and it's just a straight line going forever. And then if we had something like x equals 2, then that would be somewhat like this. So that would be at x equals 2, just make a straight line down. So here, only an x-intercept, no y-intercept, goes on forever. So that is where straight lines come on a graph. Linear graphs are usually look like this. If they don't look like this, then they look like either one of these. And then now let's talk about perpendicular and parallel lines on a graph. So no, I didn't draw this on a graph, but usually if you see parallel lines on the graph, that means that, let's say this is y equals mx plus b, right? Well, let's say this is at an angle going this way. Okay? So if we have something like that, then the slope would be the same, but the y-intercept will be different for the two lines. So let's say the line for this is y equals 2x plus 3. Then this line is going to have something like y equals 2x plus, since this line is lower, it's probably going to be somewhere like 1, around 1. And we wouldn't know the exact value on this until they give us points at it. So let's just have this as an example. And if you want to calculate, if they give us one of these and they give us a point at this, then it's easier to calculate the equation of this, right? So if we were given y equals 2x plus 3, and that's us to find the graph of, let's say this is L and this is M. The graph of M is this. What is the graph of L is this. What is the graph of M? Right, and they give us a point that is, let's make it really easy. So let's say that's like 1 comma 0, right? We are, oh wait, let's just go by 0 comma 1 because why not, right? So if we're given the y-intercept here, but if we were supposed to use this equation to find it, we would say y equals, we know they're parallel, so the slope is the same, 2x plus b. And to find that, you just plug this in, which would be 0 equals 2 times 1 plus b. So b is just going to be negative 2, right? So that will be your y-intercept, and then since I asked you to find the graph, you have to write down the graph. Cool, that's it. Pretty simple, right? Now, we know this, and I did that wrong. I did that for the graph of 1 comma 0, for the point of 1 comma 0. Okay? So if the point given was 1 comma 0, they always give you a point that is on the graph of the one you're trying to find. So don't confuse that with the one you're already given and try to just find the values, because that wouldn't work out. And now let's talk about perpendicular. Now, perpendicular are a little different. So we know perpendicular lines are at a 90-degree angle, and they always intersect at one point, and then they're also going to infinity. Parallel lines never intersect. They just keep going forever, never intersect, never meet each other. They're the same, just never meet each other, okay? And then for perpendicular lines, our graph is going to be, if we have something like y equals 2 over 3x plus 7, okay? If we have something like that, then let's say this is for our graph L and this is our graph M. If you have to find M, then that would be basically, it would be the reciprocal, the negative reciprocal of whatever your slope is. So that would mean that the slope of the new line, the perpendicular line, would be negative 3 over 2x plus whatever the b value is, which we are not given any points here, so we can't find. If we were given points, we could just plug it into this and then find the value of b, just like we did for the parallel lines. So that is all we have with perpendicular and parallel, and these are all on graphs. So they're now just going to give you two lines to graph and call it a day. It's always on a graph, and they always give you at least one equation and 1 point. So that's how you find it if you were given an equation and a point.
Okay, now we're gonna look at angles on a straight line. So basically, starting off like easy, a straight line has 180 degrees. Let's talk about vertical angle. Vertical angles basically like you can have them at any angle like that, maybe, but like it basically states that and this angle would be the same, and this angle and this angle would be the same. So if this is 30, this would be 30, and then this should be 60, this would be 60. Or something like that, okay? Basically that. So all you need to know, if that's 30, this would be 30 or any other number, okay? Now let's look at alternating angles. These basically, when you have two parallel lines and a line is going through them like that, like at a slanted angle or like, anyway, this angle and this angle would be the same. Just look at it as a Z. This looks like a Z, right? You can think of it that way, and that angle would be the same. Now let's look at corresponding angle. This basically when you say similarly when you have like a two parallel lines and you have like a line going on, this states that that angle and this angle will be the same. You can look at it like it kind of looks like an F, right? That's the way to remember this. So it can also be this angle and this angle being the same too. Okay? Basically that's corresponding angle. And then you have co-interior angles. So this basically means that if you have two angles like that, when you intersect a line between parallel lines, it add up to 180 degrees. So in this case, this is a different angle, of course, and this would both add up to 180 degrees. Finally, let's look at some small angles, like types of angles, like in mathematics that you need to know for geometry. So we have acute angles. These are like less than 0 degrees. So I mean more than 0 degrees, but then they're less than 90 degrees. So they're the smallest angles. And then we have the right angle, which is perfectly 90 degrees, like Kritika said before. And then we have the obtuse angles. These are more than 90 degrees, but they're less than 180 degrees. An example would be that. And then finally, we have the reflex angle. This is basically like you have it kind of looks like an acute angle, and you have out of it. So like acute angle is inside of it, right? This kind of looks like exterior of that, right? And basically because of that, it's going to be really large. So it's going to be like from more than 180 degrees, but less than 360 degrees. So almost like a circle, but it should be less than a circle. And that's it for like angles on a straight line and linear graphs and how straight lines are used on those. And also what's the difference between parallel and perpendicular lines.
And straight lines are always supplementary angles. They're always 180, like Vasya said. So that is all we have for you today. Do remember all of this, all of the graphs, they're very important. And all of those too, because they're really important too. So basically everything we taught you today is really important. So You remember that, do some questions on it, search up some questions on straight lines or some questions on linear graphs or some questions on angles. And you can definitely do that and get to become masters at it.
Yeah.
You guys are geniuses. So see you in our next video then.
Bye,
Bye.
Stepsters.